Hello students, welcome to Akshara 8 Foundation. So today we are going to see the new chapter and interesting chapter in the 6th class, that is magnetism. Okay. So what is magnetism? The branch of physics which studies deals with the magnets and its properties. How the magnets works. So in our generally in our day-to-day life we will see magnets will play the role. Okay. So then we should know about the magnets and magnetic properties. Okay, then so that we can utilize them in proper way in our daily life. Okay, so now we are going to discuss about the magnets and magnetic properties of light in the chapter of magnetism. Okay, then it was started this magnets and magnetic properties. It was started uh, in the early BC, 800 BC. Okay, so how it was started there? So it was invented that magnetic properties and magnets are the material was invented or discovered surprisingly by sudden. By it has discovered there. Okay, so we know that shepherd person Magnus, his name is Magnus, and he went to take care about his sheep. Okay, so suddenly whenever he roaming their field there. Okay, so there he has his shoe got stuck in some material there. Okay, so his shoe, the sole of shoe has the iron material which is made up of iron. Okay, so then that has stuck with certain material, and he's trying to pull out his leg from that material, but it is not possible there. So he used more force than it will be come out from there. So then suddenly that material. So he started thinking about that. So that material is called the by his name. It has came there. His name is Magnus, and then that material is called there. That is a ore of iron material. Okay, ore of iron material. So that material called magnetite. Okay, its name is called the magnetite. Magnetite. So this magnetite, the chemical form of the magnetite is Fe3O4. Fe3O4 there. Okay. So this material was started. This is a natural magnet which is available in the nature. So this will be the natural magnet. Natural magnet. Natural magnet. So by that shepherd person's name, magnet, this name was called, so from this magnetite, so that material, the iron ore is called Fe3O4 is called as a magnetite, magnetate material, and so it is a natural magnet, it is a iron ore. So then this name, from this, the material is called the magnet. So then what is a magnet? We will see here the magnet there. Magnet is nothing but, so it is a substance which attracts the magnetic materials. Is called the magnet. The substance which has the property of the substance which has the substance which has the property of attracting other substances towards it, other substances towards it is called magnet, is called magnet. Okay, so the substance which attracts towards it, that substance is called the magnet. So there are two types of magnets are there. Natural magnets and artificial magnets. Artificial magnets. So these artificial magnets are man-made magnets, and natural magnets are called naturally available materials there. Okay, so natural magnet is example of natural magnets, or we can say it is, so the magnetic materials are the magnets which are available in the nature. Okay, so they are known as the examples of that natural magnets are magnetite and lodestone. and lodestone. So this is also known as the lodestone. Okay. So the lodestone, the chemical combination, chemical formula is Fe3O4, Fe3O4. And then artificial magnets there. So artificial magnets are, they are made by the man. So the magnets which are made by the person, that is called the magnetic artificial magnets. So there are many examples of these artificial magnets. They are like bar magnets are there. Bar magnets, horseshoe magnet, horseshoe magnet, horseshoe magnet. Okay. So then button magnets, button cell magnets, circular magnets, and we have the electromagnets. So these are the magnets. The magnets which are available in the nature, they are called as a natural magnets. And the magnets which are made by the person, they are known as a artificial magnets are the man-made magnets. They are the bar magnets and horseshoe magnets. Different types of magnets are there based on the shape which is made. So by the person, it is called the artificial magnets there. So this in artificial magnets and natural magnets. See, in the artificial magnets again we have the two types of magnets we have there. Okay, these natural magnets are like a permanent magnets, and in artificial magnets some are like, suppose if it is say take their electromagnets. Okay, they are the temporary magnets there. Okay, so like we have the two types of magnets based on its property, based on the property. If the magnetic property has last long time, then they are known as here permanent magnets, and the magnetic property lost. Okay, so then that magnets are known as the temporary magnets. So based on the magnetic property lost in it. Okay, based on that, there we have the two types of magnets there. So okay, first one we can write there temporary magnets and permanent magnets there. Okay, we'll see now types of magnets there. Temporary magnets, so and second one is permanent magnet, temporary magnets and permanent magnets. So the magnets in which the magnetic property of it is lost for lesser time, they are known as the temporary magnets. So and the permanent magnet means once a magnetic material is made into the magnet there, then that it will be the permanent. The magnetic property in it is permanent there. They are known as the permanent magnets there. So we can write here the example of these temporary magnets are electromagnets. Electromagnets are temporary magnets there. So electromagnets are nothing but we are going to see in this next synopsis. About that we are going to learn there. Means whenever the electric current passes through it, then only it will act like a magnet there. Otherwise, it will be like a normal material there. Okay. So now the permanent magnets there. So naturally available material like magnet, they are known as the permanent magnets, and the magnet which are made up of steel. Okay, they will be act like a permanent magnet there. So nickel, cobalt, there are the different types of magnetic materials are there. Okay. So then we are going to see now the magnetic properties like properties of the magnets we'll see there. Okay. So permanent magnets are examples of permanent magnets. We can take here magnetite or lodestone. Or we can say here lodestone we can write that like that. We have the permanent magnet in which the magnetic property lasts for longer time there. Okay. Now, so that is about the synopsis 1, and in synopsis 2 we have the properties of magnet there. Okay. So now we are going to see here synopsis 2. In In synopsis 2, we are going to learn about the magnetic properties. Okay. So now we'll see here synopsis 2. So properties of a magnet. What are the properties the magnet has? Okay, that we are going to see now. Magnetic properties. Magnetic properties. Magnetic properties. Magnetic properties. Okay. So first one. So first property, we have the attractive property. So attractive property of a magnet. Attractive property of a magnet. So due to this property only, the magnet has this magnetic material. So lodestone has discovered. Okay. So then this every magnet will have the attractive property. Suppose near to it, near to the magnet. Suppose here the magnet is there. Around this, any magnetic materials are kept there. They are all coming. They will be attracted towards this, and they will be come and stand on this magnetic material. They will be come here and close. They will be attached to this the magnetic material there. All will be come close to this substance there. Means it will be have the attractive property there. Okay. So that property is known as attractive property of a magnet there. Attractive property of a magnet. Okay. Next one is directive property of a magnet. So second one is directive property of a magnet. 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 So this directive property is nothing but, suppose any man-made magnet, if you take their bar magnet, if you consider there. So bar magnet, it will be has the two poles. So this is a north pole and south pole. If it is tied with the rope, string, and it is suspended in the air, then it will be the north pole of the bar magnet will show the geometrical north, and the south pole will be shows the downwards there. So south pole of the north pole of the bar magnet will be towards, it will be directed towards the north pole of the earth there. Suppose here the earth, so toward the earth it will be substandard there. So now this will be shows the north pole will be shows the, it will be directed towards the north pole of the earth, and the south pole of the bar magnet towards the south pole. It will be directed towards the south pole there. Okay, this nature of the bar magnet is said to be the directive property of the magnet. Directive property of the magnet. And one more property, so pair property. Pair property of a magnet. Pair property of a magnet. So pair property means here the bar magnet has the two poles. So north pole and south pole there. Okay. Suppose this bar magnet is cut into the half of, okay, cut into its perpendicular to the axis. Then the two pieces will have again, it will be act like a magnet there. So this piece, one piece will be have the south pole and this side will be have the north pole. So like that, these two will be have the, so individual particle. Like how many parts you made there? So those all individual parts will be act like a individual bar magnet, and they will be have the pair of poles. Okay, the pair of poles. Now single pole does not exist in the magnet. So that is that property is called the pair property of a magnet. Okay. So now next one we are going to see here. Understood no? So this is pair property means the magnet is made, cut into the parts there, in different parts. Each and every part will have the pair of these poles there. Okay, suppose it is cut into half there. The two parts will become again, it will be act like a individual magnets, north pole and south pole. Okay, like how many parts you made there? So each and every part will have the individual magnet. Okay. So now next one is here for the bar magnet we have seen the pair of poles there. So north pole and south pole. North pole and south pole. So at the pole in the bar magnet, at the edge of the bar magnet, the magnetic property of the body, magnetic property of this magnet will be strong. Means they are the poles. At the poles the magnetic nature will be stronger. Stronger magnetic pole strength will be there. So these two will have the certain attractive property, stronger attractive property at the edges of the bar magnets there. So and these are known as the poles. So magnetic poles, north and south, north and south. These are known as the magnetic poles. Okay. So each and every pole will have the strong attractive property, then that strong attractive property is known as a magnetic pole strength. Magnetic pole strength. So now here this based by using this based on the property of this attractive property of this pole or pole strength, based on the pole strength, suppose if the like poles are kept near to each other, okay, then they will be repulse each other there. Unlike poles if you kept there, suppose here you see there, here this is this whole bar magnet has cut into half, then these two faces will be act like here south pole and north pole, again they will be attracted to each other and it will become one single magnet there. So now if you brought there here north pole and north pole or south pole near to it, then they will be moving away from each other. They will be repulse each other there. So that property means here like poles, unlike poles or like poles. So suppose if you take their like poles, so unlike poles you take there, unlike poles of a magnet, unlike poles of a magnet attracts each other, attracts each other, attracts each other there. So like pole of the magnets, so like pole of like poles of magnet, poles of a magnet repulse each other, repulse each other, repulse each other. That is the property. So like poles will be attracts, like poles will be like poles repulse each other and unlike poles are attracts each other there. So that is another property of magnet. And here the test for the magnet there, to test the magnet whether it has the, whether the magnet has the magnetic property or the not. So then how can we test it there? So for that the test, so sure test of the magnetic property, okay, sure test of the magnetic property. So that property is called the repulsion. Repulsion is the sure test of a bar magnet there. Okay, now next property is sure test. Sure test of a bar magnet. Sure test of a magnet. Sure test of a magnet. So here the repulsion is, repulsion will be the sure test. Repulsion, repulsion of a magnet, repulsion of a magnet is the sure test of a magnet there, because whenever they are going to repulse there, so then so the strong repulsion will be takes place when the like poles are brought near to it. So then, so that will be the repulsion will be the faster than the attraction there, okay. So then the repulsion can be taken as the sure test of the magnetic material there, magnetic property, okay. So now here these are all the properties of the magnet. Now we are going to see here some of the terms related to this magnet we are going to learn now. So then we'll see here terms related to the magnetic property of the magnet there, okay. Terms related to a magnet, terms related to magnet. See here we have seen their pole. So first term is a pole of a magnet there. So our magnetic poles we can see here, magnetic poles. First one is we can write here magnetic poles, magnetic poles. So in the property we have seen there pair of poles we have seen there, means the magnetic pole is nothing but it is the magnetic poles are, we have for the bar magnet we have two types of poles, north pole and south pole we have seen there. Magnetic pole is nothing but it can be defined as the point where the point in the bar magnet, the point in the bar magnet or a magnet, point in the magnet where large attractive property exists. is called or called magnetic poles, are called magnetic poles. Okay. So poles are nothing but the point on the magnet there where they have the more attractive property, large attractive property. So they are known as the poles of the bar magnet there. So that is the reason why, suppose if you take a bar magnet, at the edges of the bar magnet, more attractive nature will be exist there. So that edges are called as north pole and south pole. It is given as north pole and south pole. These two poles are two types. One is the north pole and south pole. Second one is the south pole there. South pole. So north pole and south pole. So from the north pole and south pole, there is a magnetic lines of forces will be travel from north pole to south pole. Okay. And that north pole is denoted by here capital N, and south pole is denoted by the letter capital S. Capital N and capital S. So now each and every pole, will have the pole strength. It has certain strength of attraction. Okay, the strength of attraction of a magnetic poles are known as magnetic pole strength. Second one we are going to see here, magnetic pole strength. Magnetic pole strength. Pole strength. Okay, so the magnetic pole strength is nothing but again here north. Magnetic pole strength of north and magnetic pole strength of south we can write here. So magnetic pole as a whole here, the magnetic pole strength is nothing but the strength of a pole of attraction of the magnetic materials is called there. Okay, they are known as the strength of attraction, the strength of attraction of magnetic materials, is known as magnetic pole strength. Magnetic pole strength. Magnetic pole strength. Magnetic pole strength. So they have the attractive property. So each pole will have the attractive property. So then that the strength of the attraction of the magnetic materials, they are known as magnetic strength. And for the bar magnet, suppose if you take a bar magnet, so for the bar magnet there are two axes will be present there. So one is the magnetic axis and another one is the equator, magnetic equator there. Okay. Suppose we'll see them here. We'll see first one magnetic axis and next one magnetic equator we'll see here. Okay. So this is about the terms related, and next one we'll see there here magnetic axis. Next one is magnetic axis. So next term is magnetic axis. Magnetic axis. The magnetic axis is nothing but the line, imaginary line passing through the north pole and south pole of a bar magnet there. So the line which is passes through both north pole and south pole, that axis is known as magnetic axis. This is a magnetic axis. Okay, magnetic axis. And fourth one, magnetic equator. Magnetic equator. So magnetic equator is nothing but the line which is passing through the center of the line which is passing through the center of the bar magnet and perpendicular to the magnetic axis. So this is called the magnetic equator. Magnetic equator. Magnetic equator. Okay. So here the line passing through the center of the bar magnet and perpendicular to the magnetic axis is known as magnetic equator. Magnetic equator there. Okay. And now here now the magnetic length. So what is the magnetic length? And in the magnetic length, there are two types are there. That also we'll discuss. Magnetic length we'll see here now. So the first one, magnetic length. Magnetic length. Magnetic length of a bar magnet. Magnetic length of a bar magnet. So magnetic length is denoted by here L, capital L. So how it is? The length of the north pole, the distance between the north pole and the south pole. Suppose if it is a bar magnet is there, the length between this north pole and south pole, that is called the that is the length. That length is called, the length between the north pole and south pole of a bar magnet is known as the magnetic length. So here L is equals to, we can write here 2L. Capital L is equals to small 2L there. Okay, so here and small L is nothing but the center of the magnet to the north pole and center of the magnet to the south pole. That is L there. And the length between the north pole and south pole is called the magnetic length. And next one we have the geometric length of a bar magnet. So geometric length of a bar magnet. Length of magnet. Okay. So that geometric length, okay, that is called the distance between the edges. The distance between the edges of a bar magnet, that is called the geometric length. That is called geometric length. Okay. So now here we have the relation between this magnetic length and the geometric length. So geometric length is nothing but the distance between the two edges of the bar magnet. The two edges of the bar magnet. What is that edge is nothing but the that length along the magnetic axis. The length between the edges of the two magnets and along the x-axis, along the magnetic axis otherwise. Okay. So that is called here geometric length. Now there is a relation between these two, magnetic length and the geometric length. So this magnetic length is 5/6 times of the geometric length. So this is an important relation. The magnetic length is 5/6 times of the geometric length there. Magnetic length is 5/6 times of the geometric length. So geometric length is greater than the magnetic length. So this length is greater than this magnetic length. No? Magnetic length is nothing but the distance between the north pole and the south pole is called the magnetic length, and the distance between the, simply we can say the geometrical length of a bar magnet. Okay, or we can say here the distance between the edges of the bar magnet along the magnetic axis is known as the geometric length, and the distance between, here the relation between this magnetic length and the geometric length is L is equals to 5/6 times of the geometric length. Okay, so this is about the concept, this is about synopsis 2. Okay, so clear now? So now next we are going to see here synopsis 3. So later on in the next class we are going to solve all the numerical problems in all the synopsis there. Okay, and third one is here methods to magnetize a substance, magnetic substance there. Okay, so there are we have different types of magnets we have seen, like natural magnets and the artificial magnets. Then how the artificial magnets can be made. Okay, so there are certain methods are there. So in the synopsis 3, so that methods we are going to see. Okay, now the synopsis 3. Okay, this you note down, children. Okay, now we are going to see now synopsis 3. Synopsis 3 explains about how to make a magnet, magnetization of magnetic materials or demagnetization of magnetic materials, about that, and what are the permanent and temporary magnets. About these all we are going to study here in this synopsis. Okay, so now here magnetization of a magnetic materials, magnetization of a magnetic materials. Magnetization of a magnetic material is there. Okay. So how can we make the, so otherwise we can say here there are methods. Simply we can write here methods of magnetization. Methods of magnetization. So magnetization is nothing but making a magnetic materials into magnet. That is called the magnetization. So now here we'll see there are four types of methods are there. So that we are going to see here. First one is single touch method. Okay, magnetization by single touch method there. So here we can write there. First one is single touch method. Single touch method. First method is single touch method, and second one is double touch method there. Double touch method. Double touch method. And third one we call here induction method. Induction method. Induction method. And fourth one we know that fourth one is called the electrical method. Okay, electrical method. Electrical method. So now we are going to see here one by one single touch method. So what is the single touch method? How the magnetic materials can be magnetized. Okay. So means suppose consider this is a magnetic material and this one is a non-magnetic material there. Okay. So then what they will do there is, otherwise we can take their nails. We have the nails, no? So then how the nails can be magnetized there? Okay. So simply what it will do there, suppose it is a magnetic material and this is a natural magnet. Then here if you touch the north pole of the bar magnet, it is kept in physically contact with the non-magnetic, this unmagnetized magnetic material. So it is in physically in contact then, so this magnetic material will become a magnet there. Okay, that method is called method is called single touch method there. Single touch method. So now we suppose here let us consider this is a nail. Okay, we consider their nail there. So here there is a physical contact with the north pole of the bar magnet, or it will be keep on in contact with this bar magnet. So then it is a single touch method. Only one pole of the bar magnet will be in contact with this magnet. Then this nail will become a magnetic material there. That is called the single touch method. And then double touch method. So in the double touch method, there are two magnets. Will be kept in contact, physically in contact with the magnetic material. Suppose here we can see there, this is a south pole of a bar magnet, and here we can keep the north pole of the bar magnet there. So here the north pole of the bar magnet, they are in kept contact with the magnetic material. Then this magnetic material, that like it can be the iron, anything there. Okay. We have the magnetic materials and non-magnetic materials are there. No, magnetic materials are nothing but the materials which are attracted, the substances which attract to the magnets is called the magnetic material. The material which does not attract to the magnets are known as non-magnetic materials. Like non-magnetic materials are, we know that they are the wood, plastic, which they cannot. So even the silver and the iron, iron will be magnetic material only. Silver, gold, they are the non-magnetic materials there. They will not attracted by the magnet there. Okay. So the next one is induction method there. So induction method is nothing but, so this method is generally used for temporary magnets there. They are nothing, they not in physical contact like this single touch and double touch method. So one magnetic material is kept near to the another magnetic material, means one bar magnet will be kept, a natural magnet will be kept near to the non-magnetic material which not has the magnet property. Okay. So then what happens there, due to the attraction, so due to the attraction of this magnetic property of the magnet, natural magnet, so then after some time, due to the induction method, the magnetic material can be magnet there. So then that is called, whenever it is there, it is in near, it is in contact, it is in the vicinity of this natural magnet, then this magnet will become a magnet, and if there is no natural magnets beside it, then it will be not act like a magnetic material there. So this is a temporary magnets. So by using this induction method, so means there are two. So one is a magnetic material, otherwise we can say here it is a nail we can take here. So this is a nail, and here we'll keep a bar magnet there, north pole of a bar magnet. It is in near to this, then this will become a, due to the attractive property of the natural magnet, it will become a magnet there. So if there is no, if you remove this magnet, then it will not act like a magnet. Okay, the magnetic property, the nail will be lost whenever we remove the natural magnet from that there. So that property is called the inductive property. It is for the temporary magnets there. So that method is temporary magnet. So even the next one is electrical method there. Electrical method. So whenever, so this electrical method we have seen the electromagnet. No? Whenever the electric current passes, okay. Suppose through the conductor, if electric current passes there, there are two properties will be, two effects will be takes place on the conductor. So they are known as the heating property and the magnetic property. Means if the current passes through this, there is a heating effect will be there. After removing the electric current from here, then if it touch the metal conductor, so it will be get heated there. Okay. So then along with the heating effect, there is a, around this conductor, there is a magnetic property will be there. So then, so if you send, now if this conductor is made into coil, then it will be exhibit more magnetic in nature there. Okay. So then here and this coil, in this coil, if any metal is kept inside this coil there, okay, then the magnetic nature it will be increases in it there. And this ends, two ends of this, the two ends of this is connected to the battery, and here the switch. Then when the switch is closed there, from the cell there is a electric current passes there. So when this will be act like magnet there. So this is called the electromagnet there. Electromagnet. Whenever the current passes through this coil there, so this whole thing, it will act like a electromagnet, but it is a strong electromagnet. So this is used, the electric method is used to make the stronger electromagnet, but it is also temporary magnets only. Okay. Whenever we need the magnetic in nature, so then the switch is on, the current passes through this coil and this core, means on the metal. Through this coil there is a electric current passes there, then magnetic property will be increases in it, and now this total arrangement will be act like a magnet. It will be act like a normal bar magnet there. Okay. So that device is called that. This device is called the electromagnet. Electromagnet is used. Okay. So this electromagnet is also, it is a temporary magnet, and this is used to find this electric method is used to find the strong magnets there, strong magnets. So then this electromagnets or electromagnet will be used in many, there are many applications of this electromagnet there. Okay. In the MCB switches, this electromagnet will be present there. Electrical bells, the electromagnet will be present there. Okay. So then in loudspeakers, in telephones, okay, and ammeters and gallanometers, like we have the devices. So in our day-to-day life, we'll use there. In the laboratory also, we'll use some methods, ammeters and voltmeters, to find the electrical current in the circuit and to find the electrical voltage across the electrical appliances. So in those devices, these electromagnets will be used. So whenever the current passes through this conductor, through the coil, it will act like a magnet there. So this is about the electric method. And even so here these are the methods we can magnetize a magnetic material. So then if you want demagnetize it, so if you want remove the magnetic property from that material, so then what are the methods are there to demagnetize the magnetic property from the magnetic material? So then there are certain methods are there. Okay, those we'll see there now. Okay. So these are all the methods to magnetize a magnetic materials. Okay. So now we'll see there methods of demagnetization. Now we are going to see here methods of demagnetization. So methods of demagnetization. Demagnetization is nothing but the process of removing the magnetic nature from the magnetic materials is called the demagnetization. Means to remove the magnetic property from the magnetic materials. That is called the demagnetization. Demagnetization. So methods of demagnetization. Methods of demagnetization. Okay. So first method, by hammering. Suppose in the previous methods we have made a steel or a nickel rod into a magnet. Then how that magnetic property has to be removed from that material there. So then this, suppose if we consider the bar magnet, if we hammered it, okay, if this strongly, if it is beaten by a rod or anything, so by hammering. So if you hammer it, then it loses the magnetic property. Or so second one is heated. If this if the magnet has get heated there, so then also the magnetic property is losses. So then rubbing. So either due to the rubbing of this magnet to the floor, other material there. So by the friction also the magnetic property will be, so the magnetic property losses there. So rough handling, if it is used, okay, roughly, rough handling also, rough handling of the handling of a magnet there. So if the magnets are used vigorously, then the property of the magnetic property will be losses. It can be demagnetized there. Okay. So then if it is dropped from certain height there. So if the bar magnet is dropped from certain height, dropping of a magnet from greater heights. So dropping of a magnet from great height, from greater heights. So then the property of a magnet losses there. So these are the, and heating. So this is heated at high temperature. So at high temperature it is get heated. High temperature, if it is heated there, so then the magnetic nature will be lost from that magnet. So these are the methods to demagnetize the magnetic properties. Okay. Understood now? So now we are going to see next uses of magnets. So there are many uses, or there means applications of magnets there. Applications of magnets. There are many applications are there, the magnets. Okay. So by using these magnets, we can make the magnetic compass. Okay. Magnetic compass is a device which shows the directions in the sea or in the air there. Okay.